There is a silence that speaks volumes, a profound quiet that settles not in the absence of noise, but in the absence of life's fundamental rhythm. It is the sound of a riverbed that has forgotten the touch of water, a geological memory etched in patterns of desiccation where the ghost of a current can still be traced in the fractured earth. Each crack is a testament to a thirst that has gone unquenched for seasons, for years. It is the whisper of wind across a landscape of cracked, sun-baked earth, a sound that carries no moisture, no promise of relief. It is the sound of soil turning to dust, of potential turning to memory. This is a place where life once teemed, where the air hummed with insects and the banks rustled with movement, but now retreats, pulling back to the very margins of survival. This is not a vision of a distant, desolate planet, captured by a robotic rover millions of miles away. There is no comfort in that distance. It is a portrait of our own world, unfolding in slow motion before our very eyes. A postcard from a future we are actively creating, one dry day at a time. We begin our journey here, at the edge of what was, standing on the floor of a reservoir that no longer holds a memory of rain. We walk on ground that should be hundreds of feet beneath the surface, a place meant for the deep, cold quiet of a lake, now exposed to the harsh glare of the sun. The concrete walls of the dam, once mighty structures holding back the immense power and promise of a captured river, now stand as monuments to a vanishing resource. They are tombstones for a body of water that has passed on. Their surfaces are stained with the high water marks of a more abundant past, a ghostly ledger of the volume we have lost, year by year. Each line is a high tide of a bygone era, a reminder of a fullness we took for granted. This is the front line of a quiet, creeping crisis, a battle being lost not in a thunderous clash, but in a silent, steady retreat. A crisis that does not always announce itself with the roar of a storm or the tremor of an earthquake. Its arrival is far more subtle, more insidious. It comes with the subtle, relentless retreat of the blue lines on our maps. The lifelines of continents, the veins of our world, are thinning, fading, and in some places, disappearing entirely. We see it from space, a vantage point that offers no filter, no comforting illusion. This orbital perspective reveals the stark reality of our planet's health, showing us the spreading scars of drought in shades of ochre and brown, the great arteries of the earth, rivers like the Colorado, the Indus, the Yellow River, names that echo with the weight of history and the rise of civilizations, are shrinking. Once mighty forces that carved canyons and shaped continents, they now struggle to complete their ancient journey to the sea. Their deltas, the fertile crescents of silt and sediment which have nurtured civilizations for millennia, are receding.
The land itself is shrinking, starved of the deposits that once replenished it, surrendering to the advance of the sea. The Great Lakes, the inland seas that once shimmered from orbit, are fading, leaving behind ghostly white plains of salt and dust, where fishing boats lie stranded miles from any shore. From a distance, our planet is a breathtaking swirl of blue and white, an ocean world teeming with life. This image, our iconic blue marble, is a beautiful deception. It suggests a world of infinite watery abundance. While over 70% of the Earth's surface is covered in water, the vast majority of it is saltwater, undrinkable, unusable for the crops that sustain us. Only a tiny fraction, less than 3%, is freshwater. And of that small portion, most is inaccessible, locked away in glaciers, polar ice caps, and deep underground. The water we depend on for everything, for drinking, for sanitation, for industry, for life itself, amounts to less than 1% of the total, a fragile, finite resource. The consequences of this scarcity are felt most acutely in the fields and farms that feed our world. Agriculture is the single largest consumer of freshwater globally, accounting for an astonishing 70% of all water withdrawals. It is the thirstiest endeavor in human history. Each grain of rice, each ear of corn, each piece of fruit is a product of water. It is the invisible ingredient in every meal we eat. Food is, in essence, embodied water. A simple loaf of bread can carry a hidden footprint of over 1,000 liters. A single steak, an order of magnitude more. We don't just eat food, we consume the water it took to grow it. The sight of vast, irrigated circles in the middle of a desert speaks to our ingenuity, our ability to make the desert bloom. But it also reveals the immense pressure we are placing on our most vital resource, painting a vivid picture of our dependence and our desperation. To quench this agricultural thirst, we are, in effect, mining our water. We are drilling deeper and deeper, pumping groundwater from ancient aquifers much faster than it can be naturally recharged by rainfall. These vast underground reservoirs, which took thousands, even millions of years to fill, are being depleted in a matter of generations. We are draining the planet's savings account with no real plan for what comes after. We are borrowing water from the future to feed the present, and the debt is coming due. The image of a farmer standing in a field of withered crops is not just a personal tragedy, it is a warning sign for our entire global food system. It is a glimpse into a future where the cost of water is measured not in currency, but in hunger. This is the story of our time, the story of water. As our world has grown thirstier, as rivers have dwindled and ancient aquifers have run dry, we have looked to the ocean as the ultimate solution. For decades, we turned our gaze to the immense, seemingly infinite reservoir of salt water that covers over 70% of our planet. It holds 97% of all Earth's water, a staggering volume that has always represented both a barrier and a tantalizing promise. If only we could drink it. The concept is simple and elegant in its ambition. If we can strip the salt from seawater, we can forge a virtually limitless supply of fresh water. This age-old dream, once the domain of shipwrecked sailors boiling pots of seawater, has been realized on an industrial scale. This process, known as desalination, has been hailed as a miracle of modern engineering. Massive desalination plants now dot the coastlines of arid regions from the Middle East to California and Australia, humming fortresses standing guard against drought. They are monuments to our ingenuity, our refusal to bow to the constraints of geography. The workhorse technology behind most modern desalination is a process that sounds like something from a science fiction novel, reverse osmosis. To understand it, we first have to appreciate its natural counterpart, osmosis. This is the fundamental tendency of water to move across a membrane from a less concentrated solution to a more concentrated one, striving for equilibrium. It's how plants draw water from the soil, and how our own cells regulate their internal environment. Reverse osmosis is the act of fighting this fundamental law of physics. It works by forcing salt water at extremely high pressure, up to 80 times atmospheric pressure, against a semi-permeable membrane. We are literally overpowering nature, reversing the water's natural desire to flow. The membrane itself is the heart of the system, a marvel of material science. It's a superfine filter, a sheet of advanced polymer thinner than a human hair, engineered with pores so small they are measured in nanometers. These pores are just large enough to allow individual water molecules to pass through, but they are designed to block the larger salt ions, which are typically surrounded by a shell of water molecules, making them too bulky to squeeze through. The membrane also blocks nearly everything else: bacteria, viruses, minerals, and other impurities. What emerges on the other side is water in its purest form, stripped of its oceanic identity and rendered drinkable. It is a remarkable feat of physics and material science, a testament to our ability to manipulate matter at the molecular level. But this victory against nature is not without its consequences. However, this battle comes at a significant cost. Pushing water against its natural osmotic gradient requires an enormous amount of energy. It is a brute force physical confrontation, and the energy bills are staggering. Desalination plants are profoundly power-hungry, often ranking among the largest electricity consumers in their regions. In many parts of the world, this energy is supplied by burning fossil fuels, meaning that our quest for fresh water directly drives carbon emissions and exacerbates the very climate change that contributes to water scarcity. The cost of this energy is the single largest factor in the price of desalinated water, making it far more expensive than water from traditional sources like rivers or groundwater. This high price tag creates a deep social inequity. It puts this life-giving resource out of reach for many poorer communities and developing nations. Desalination becomes a solution for the wealthy, for coastal cities and affluent industries, not a universal panacea for global thirst. Furthermore, the process creates a problematic byproduct. For every liter of fresh water produced, a liter or more of highly concentrated salt water, a toxic cocktail known as brine, is left behind. This isn't just extra salty seawater. This toxic, super salty slurry is often laced with residual treatment chemicals used to clean the membranes and prevent fouling, such as chlorine and anti-scalants. The most common and cheapest method of disposal is simply to pump it back into the ocean. Being denser than normal seawater, this brine sinks, creating dense, oxygen-deprived dead zones on the seafloor that can suffocate marine life. It can devastate local marine ecosystems and the fisheries that depend on them. In a cruel irony, the very solution to our water problem creates a new, insidious environmental problem in the very ocean we depend on. Desalination, while a vital tool in our arsenal, is not the silver bullet we once hoped for. It is a brute force approach, a technology of last resort. It is a powerful testament to both our technical prowess and our profound limitations. A reminder that even when we bend the laws of nature to our will, there is always a price to pay. The limitations of our current methods force us to ask a more fundamental question. Must our solution to water scarcity be so large, so centralized, and so energy-intensive? Perhaps the answer lies not in building bigger pumps, but in rethinking the very nature of filtration itself. This is the promise of a new technological revolution happening at the nanoscale. Imagine a technology so precise it can operate at the level of individual atoms and molecules. This is the world of nanotechnology. We are learning to build materials and devices from the bottom up, with atomic precision. At the heart of this approach are materials like graphene, a sheet of carbon atoms in a hexagonal lattice, just one atom thick. It is the strongest material ever tested, incredibly lightweight and flexible. By punching molecule-sized holes, nanopores, into a sheet of graphene, scientists can create the ultimate filter. A membrane so thin and precisely engineered it allows water to pass with very little resistance while blocking virtually everything else. It is a fundamentally different kind of filter, a molecular gate. We are learning from nature. Our cells contain specialized proteins called aquaporins that act as perfect water channels, transporting water across membranes with incredible speed and selectivity. By mimicking these systems, biomimicry, we can design synthetic membranes far more efficient than today's. This is the dawn of the planetary filter, an architecture for survival built one atom at a time. For generations, when faced with thirst, we have looked outward and downward. Our coastal cities, monuments to modern engineering, turn to the immense power of the ocean, spending vast amounts of energy to strip salt from the sea. But this is a solution bound by geography and heavy with environmental costs. Meanwhile, the greatest, most fundamental thirst on the planet remains rooted in the soil, in the croplands that feed our civilization. Agriculture alone accounts for 70% of all freshwater withdrawals globally, a staggering demand that is depleting ancient aquifers and straining our river systems to their breaking point. In our relentless search for water on the ground, we have largely ignored the vast and perpetually renewing reservoir that flows silently, invisibly above all our heads. It's a river in the sky, an ocean of vapor that holds the key to a more sustainable future. The sheer scale of this resource is difficult to comprehend. The Earth's atmosphere contains an immense amount of water in the form of vapor, an estimated 13 trillion cubic meters at any given moment. To put that into perspective, it's a volume greater than all the freshwater rivers and lakes on the planet combined. Unlike groundwater, which can take centuries to replenish, this atmospheric reservoir is constantly renewed by the planet's natural water cycle. It is a truly democratic resource, present not just over oceans but above the driest deserts and most remote landlocked regions, far from any traditional water source. The challenge has never been its existence, but our ability to access it. But what if we could actively and efficiently harvest this vapor, pulling it directly from the air on demand, wherever and whenever it's needed? This is the profound promise of atmospheric water harvesting. Early attempts like fog nets or energy-intensive refrigeration-based dehumidifiers showed the potential but were limited by specific climate conditions or prohibitive power consumption. They could only work where humidity was high or where energy was cheap and abundant. To truly unlock this global reservoir, a new approach was needed, one that could work passively with minimal energy, even in the driest places on Earth. The true breakthrough lies not in brute force mechanics, but in elegant chemistry, in finding a more passive and energy-efficient way to capture vapor. This requires a material that can act like a hyper-selective, high-capacity sponge, one that naturally attracts and holds onto water molecules from the air and then releases them with just a gentle nudge. The search for such a material has led scientists into the realm of nanotechnology to design and build materials at the molecular level. They are called metal organic frameworks, or MOFs. Part metal, part organic molecule. These are not simply mixed together. They are precisely engineered to self-assemble into a rigid, crystalline structure with a vast internal surface area and an extraordinary amount of empty space. Think of them as molecular scaffolds or programmable crystals. By choosing different metal and organic components, scientists can tune the size and chemical properties of the internal pores, designing them specifically to attract and capture certain molecules, in this case, water. The porosity of these materials is almost unbelievable. A single gram of a MOF, a small pinch of crystalline powder, can have an internal surface area equivalent to a football field. It is this immense network of internal surfaces that gives the material its sponge-like power, allowing it to passively pull in and organize water molecules from the air, even at very low concentrations. The MOF water harvesting process is a simple, elegant cycle of capture and release, powered by the natural fluctuations in daily temperature. During the cooler, more humid night, the MOF's internal surfaces passively absorb water molecules directly from the ambient air. Then, as the sun rises and warms the device, the gentle heat breaks the weak bonds holding the water, releasing it as pure vapor inside a containment chamber. This vapor then condenses on a cooler surface, yielding ultra-pure liquid water, free of any salts, pollutants, or microbes. This isn't science fiction. Working prototypes, powered only by sunlight, are already proving the concept in real-world conditions. These devices can produce several liters of water per day for every kilogram of MOF material they contain. Crucially, they can operate effectively even at a relative humidity as low as 10% or 20%, conditions found in the world's most formidable deserts, environments once thought far too dry for atmospheric water harvesting to ever be viable. While providing drinking water is a vital application, the true game changer is integrating this technology with agriculture. This is where the concept of the desert greenhouse comes in. A closed-loop agricultural system designed to create a self-sustaining oasis, a pocket of intense fertility in an otherwise barren land. It's a radical reimagining of what it means to farm in a water-scarce world. The system is a masterpiece of synergy. It effectively uses two abundant desert resources, seawater and sunlight, to produce its own fresh water and create a perfect tailored microclimate for agriculture. Hot, dry air is cooled and humidified by passing through a screen evaporated with seawater. This creates a cool, moist environment inside, ideal for growing crops, while dramatically reducing their water needs. The humid air is then condensed, often using cool, deep seawater to harvest fresh water for irrigation. This closed-loop model is incredibly water efficient, a stark contrast to open-field irrigation. It minimizes evaporative losses to the outside atmosphere and, crucially, allows for the recapture and recycling of the water transpired by the plants themselves. Every drop is precious, and every drop is kept within the system. This means high-value crops can be grown with a fraction of the water required by conventional farming. By combining atmospheric water harvesting with these advanced horticultural systems, we can push the boundaries even further, creating agricultural zones completely independent of local freshwater sources. These engineered oases represent a powerful vision for a new kind of agriculture, one that doesn't deplete the earth but works in harmony with its most abundant resources. It's a future where we can thrive in the world's most challenging environments, turning desolate landscapes into productive, life-sustaining farmland. The modern farm is becoming a vast, interconnected network, a living organism with a digital nervous system. Thousands of tiny sensors, buried in the soil, measuring moisture levels, temperature, at different depths around the root zone. All of this data flows into a central cloud-based platform. This is the brain of the operation. Powerful software and AI algorithms process the torrent of information. The AI models integrate a vast number of variables to calculate evapotranspiration, or ET, the total water lost from the field. This is the shift from reactive response to predictive. Hydration. If significant rain is forecast for tomorrow, it can delay irrigation today, saving water, energy, and preventing waterlogging. Drip irrigation is the workhorse of this revolution. Emitters deliver water slowly and directly to the root zone, drop by drop. As the sprinkler moves across the field, it constantly adjusts water per nozzle according to a prescription map generated by the AI, like a giant rolling inkjet printer, painting the landscape with precise, variable water. Precision can increase water use efficiency by over 90%. Grow more food with less water, a critical capability as population and water stress rise. The central question is one of ownership and access. When we perfect the technology to pull water from the air, who owns that water? We must build a new architecture of governance. We need international agreements to treat these technologies as a global public good. We must foster open-source innovation and create pathways for technology transfer that empower developing nations. The goal is not just to sell filters, it is to share knowledge for water security for all. The quiet hum of a solar-powered water harvester in a remote village could be the sound of a promise kept. The choice to build this future is ours. For the first time, we have the ability to not just adapt to the hydrological map, but to actively rewrite it. We can imagine an agricultural system that feeds 10 billion people while using less water than we do today. This is not science fiction. It is the tangible promise of the science we have explored. The tools to end thirst are moving from the laboratory to the landscape. The planetary filter is the first and most critical piece of a much larger project of planetary engineering, of consciously and responsibly stewarding the Earth's systems for the benefit of all life. The rewrite continues in the engineered soil. Before patents, there were commons. Long before our treaties and licenses, people carved water into culture. Stairways of stone descending into cool shadow. Silent tunnels guiding mountains melt beneath the desert. Woven nets that comb the sky for breath. In Gujarat, stepwells inverted the temple. Architecture as aquifer, prayer as maintenance, shade as technology. The community kept the ledger of water in footsteps and festivals. Across Iran, qanats ran like underground veins. No pumps, only slope. Patience, a pact between villages. Ownership was participation, stewardship was inheritance. On Atlantic ridges in North Africa, Berber fog nets lift their hands to dawn. Each bead is counted, shared, remembered. A cloud becomes a contract. These are designs without logos. Gravity, capillarity, porosity, shade, physics married to custom. They teach us that the blueprint is social as much as structural. As we debate governance, we can listen to this older constitution. Water belongs to the network that cares for it. Credit flows with labor. Access follows need. Knowledge returns to where it's used. Our planetary filter is not a break from history, but its continuation. Open source ancestors meeting open source futures. Let modern meshes learn from monsoon stairs. Let algorithms inherit the ethics of the commons. Hands still draw water at dawn. Let them also draw designs, data, and decisions, because the map we rewrite is written twice, once in code and carbon, and once in memory and stone. We have named rivers. We have prayed to them. Now in some places we give them standing. Legal personhood is a simple tool to let a river be a subject of rights, not an object of use, not human, not mystical. Recognized, represented, heard, healed. On Aotearoa's Wanganui, the law speaks the language of relationship. The river is an indivisible whole. Two human guardians carry its voice, one from the crown, one from the iwi who have kept its story. They walk the banks, keep the ledger, and answer when the river is harmed. Along the Ganges system, tributaries have been named as persons in courtrooms. The point is not punishment. It is standing. It is the right to say no, and the duty to be restored when no is ignored. Guardianship turns care into structure. It requires notice reports, remedies flows, measured discharges accounted for, habitats repaired. Accountability is no longer abstract. It becomes a path back to balance. This is ethics with paperwork, a bridge between memory and statute. Personhood does not replace custom. It codifies it. It says what ancestors practiced in steps, tunnels, water belongs to the network that cares for it. When a river can speak, we are obliged to listen. When it is represented, we are obliged to respond. Stewardship becomes shared, named, and enforceable, not as politics, but as continuity. Slow pans of water, a guardian's footsteps, a quiet court facade. The message is steady. Treat the river as a neighbor with rights, and we relearn our duties. Rivers as persons is not a metaphor, it is a method. Sensors, models, maps to make repair measurable, to make care accountable, to let living water be part of the conversation about its own future. Begin with a drop, locked in blue ice, a long telephoto hold. The glacier breathes out, the nose retreats, the ledger marks another line. Summer arrives earlier. Peak flow slides forward on the calendar. Late season thins to a trickle. A proglacial lake pools where ice once pressed. It grows, pulses, tests its moraine. Engineers add spillways. Guardians add watch lists. Downstream, gates learn new rhythms. Hydropower shifts from steady to responsive. Sediment builds. Dredgers keep the channels honest. Sensors stitch the mountain to the valley. Snow pillows stream gauges satellite albedo radar of the fern. Models translate brightness to melt. Forecasts arrive as probabilities, not promises. Communities adapt in sequences. Storage tanks fill at night. Irrigation windows move with the melt curve. SMS alerts set tap times. A village learns the week by the water. Hold on the stars over peaks. The drop leaves the glacier, crosses a dam, threads a canal, turns a turbine, reaches a tap, cold, then gone. Accounting turns care into practice. Flows measured, deficits forecast, releases timed. The glacier's account is finite. The river's rights depend on its balance, not punishment. Standing and planning. Sensors, models, maps as pages. A ledger kept in light and numbers. If a river can speak, a glacier can be counted. Our duty is to listen and keep the books. They don't roar, they breathe. Reeds exhale fog at dawn. Mangrove roots write lace in the tide. A slow pan over water the color of tea, cleared by time, sifted by life. Here, the ledger softens at the margins. Suspended mud meets a maze of stems. Pollutants meet biofilms. Pollutants meet roots. Pollutants meet silence. Clarity is earned, not rushed. Floods arrive with blunt arithmetic. The marsh answers in volume and patience. Water spreads, slows, forgets its sharpness. Storms lose their teeth in these green mouths. Underfoot, the long math of carbon. Peat stacks years into meters. Mangroves bank blue carbon in tangled vaults. A stillness that keeps the sky from rising faster. Birds lift as one. Ink blots against morning. Crabs stitch the shoreline. Fish nursery under prop roots. A heron holds the pose between breath and strike. Cut to hands. Restoration crews in waders. Bundles of plugs slid into mud. Coconut coir unrolled. Young mangles staked against the learning wind. Community calendars set by tides and moon. Soft transitions. Old channels reopened. Culverts widened to let salt and fresh negotiate. Oyster reefs seeded, living breakwaters. Fences come down so water can remember the path. Sensors join the chorus without leading it. Salinity loggers blink among the reeds. Drones map canopy. Drones map tide. Drones map recovery. Accounting meets listening, numbers held in cupped palms. A town upstream reads new floodlines. Downstream, a village plants the season's 1,000th seedling. Insurance models nod, so do pelicans. Hold on roots in clear shallows. This too keeps the books. Filtering without fanfare, buffering without blame, storing not for profit but for breath. If a glacier can be counted, a wetland can be restored. Give it room, give it time. Let the water think here, and leave fuller than it arrived. By night the city inhales. Roofs bead with quiet rain, gutters wake, downspouts whisper, cisterns tucked behind brick and ivy, a chain of small decisions adding up to flow. Cut to dawn. Control rooms glow. Pressure maps breathe in blues and golds. Ultrasonic levels in tanks. Chlorine at the edge. Turbidity where pipes turn. A hiss at 2 a.m. becomes a dot on a screen. Smart ears triangulate. A valve nods. The leak becomes yesterday. Roofs grow soft armor. Sedum holds a storm like a sponge. Courtyards trade concrete for soil and roots. Streets take a second job, permeable, patient. Bioswales sip the first flush, then the next. Underneath, vault stage water for later, not lost, just parked. The loop tightens. Roof, gutter, cistern, filter, reuse. Purple pipes carry second chances. Parks misted at noon. Cooling towers fed at dusk. Toilets unheroic and steady. Metered, yet never mean. Rain arrives hard. Models arrive first. Digital twins run the city 10 minutes ahead. Gates retime. Underpasses stay passable. Plazas take a breath and give it back slowly. People keep the rhythm. Crews swing manholes. Home barrels tick full. A school turns yesterday's storm into today's science. Accounting meets listening, again. If wetlands are kidneys, cities learn capillaries. Hidden lines, open outcomes. Let the water think here too, so it leaves wiser than it arrived. Begin at the outfall, not the river, the plant. What arrived as wastewater is now a feedstock. Screens lift out rags and grit. Air lifts the smell. The story starts once it's quiet. Macro on membranes, white bundles of hollow fibers, hair thin and patient. Water slips through pores smaller than a bacterium. Water slips through pores smaller than a virus. Outside, a living film does the rough work. Microbes eating what we left behind. Inside, the membrane does the fine work. Ultrafiltration, steady and exact. Cut to basins breathing. Blowers hum. Bubbles rise in slow constellations. This is a membrane bioreactor. Biology. Plus sieve, tuned to clarity you can measure, not guess. In a side stream, nutrients become products. Phosphorus crystallizes as struvite, sand-white pellets you can hold. Nitrogen is captured, guided back into fertilizers instead of rivers. What was a burden becomes inventory. Lab glassware reflects the room. Turbidity near zero. Conductivity logged. Microbes counted by light. UV polishes the flow. A touch of residual disinfectant keeps it clean in the miles ahead. Follow the purple pipe. The color says, not for drinking, but it is for almost everything else. Parks exhale in the afternoon, sprinklers whispering reclaimed. Sign, recycled water, do not drink. Sign, do not waste. Median trees root deeper. Ball fields stay open through August without touching the reservoir. Industry plugs in at dusk. Cooling towers sip recycled instead of potable. Heat traded for drift. Meters click, volume. Meters click, quality. Meters click, pressure. Because trust is data you can show. This is reuse without drama. Fit-for-purpose water matched to fit-for-purpose needs. Less draw from rivers, less discharge to them. The loop that began on a street moved through a plant now returns through a park. Now returns through a tower. Now returns through a flush. Quiet, continuous, normal. Wastewater becomes resource. Stigma becomes system. The city doesn't just send water back, it sends it back smarter. Follow the loop inside the gate. Valves click, pipes breathe, water works twice. Closed loop cooling first. Heat in, heat out, no river on standby. Side stream filters strip out fines. Antiscalants keep minerals from plating. Blowdown shrinks, membranes recover it back. Plate heat exchanger trades heat without trading water. Sensor, conductivity. Sensor, pH. Sensor, corrosion rate. Drift mist is captured. Towers sip less. Chillers stay honest. A loop that mostly stays a loop. Textiles next. Color without the plume. Dye bath meets ozone and light. Chromophores crack. Color drops. Activated carbon takes the leftovers. Nano-filtration separates the dyes from the salt. Salts circle back to the next batch. Enzymes shave off stubborn molecules. Permeate clears to spec. Measured, not guessed. Filtration skids roll under the line, modular and fast. Lot by lot, liters saved. Shade stays in the cloth, not the canal. Semiconductors, clean room quiet. Robots glide, wafers turn. Rinse water is pure, now it is captured. Cascade rinses become recirculation. Reverse osmosis tightens the cut. Electrodeionization polishes ions down. UV at 185 nm knocks talk to CO2. UV at 254 and keeps microbes asleep. Final filters count particles you cannot see. Ultra pure back to ultra pure with a buffer tank that never blinks. Yield holds, demand falls. Across the fence line symbiosis, one plant's waste heat feeds a neighbor's drying drum. One site's reclaimed stream supplies district cooling. Meter, flow, meter, quality, meter, pressure, meter, uptime. Alarms are rare, trends are constant. This is reuse without drama, scaled for steel. Thread, silicon, less intake, less discharge, more product per drop. The factory doesn't just use water, it keeps it working. Golden hour. A hand lifts a soil probe. Loam crumbles. Sensor blinks. Data, not guesswork. Small holder drip in Marathwada. A phone app reads VWC and tension in kPa. The line opens for 18 minutes, shuts before the sun bites. Tomatoes hold color. Yield up 9%, ET down 15%. Det lighter. Drone pass over Oaxaca maize. NDVI to prescription. AI's flag stress on the south edge. Windward sandier. Only that zone drinks tonight. A cistern lasts the week. The creek keeps moving. Pivot retrofit on high plains, wheat. Variable rate nozzles, sector by sector. Wind soil map forecast KC curve, merged. The arm sweeps. Water feathers where roots ask. Skips where clay is full. Same bushels, 22% less applied. Vineyards, riverland. Canopy temp sap flow tick upward at noon. The model waits. A cooler afternoon is coming. Deficit by design. Berry size holds. Flavor concentrates. ET trimmed without stress. Kenyan beans on half-acre beds. Solar pump hums. Tensiometers whisper. 18 kPa, enough. The AI nudges irrigations to dawn. Less loss to sky, more to pods. A field that listens gives back. Central Valley almonds. Forecast rain in 36 hours. Set points rise. Irrigation delayed. Storm finishes the job. Nitrate stays out of the groundwater. Orchard stays on schedule. Satellite pass, 10 meters at a time. A dashboard draws blues and golds across the plain. A grandmother taps her screen. A grandson checks the header tank. Translation: one more day at 60%. Trust, learned harvest by harvest. Case to case, the pattern holds. Fewer hours, smarter inches, roots in conversation with sky. Yield steady or better. ET lower. The story is not gadget, it's attention, amplified. The fields are not thirsty, they are speaking. Now we hear them. Mulch lays down like bark on a drum. First drops land and bead, then sink, no splash, no sprint for the ditch. The surface stays cool. Cover crops roll and fold a living blanket. Roots knit a lattice prying open pores. Water finds pathways, soil remembers how to drink. A slice of profile, dark crumbs round and firm. Air and water share the rooms between. Glints of moisture hold to organic matter, not clutched, not lost available. Contour lines curve with the hill. Rain slows, pauses, listens. The sheet flow becomes a quiet seep. Gullies don't get their start. Time lapse. A seed splits, root hairs thread into fungal lace. Capillaries extend the reach. Every millimeter mattered yesterday, matters more today. Raindrops on mulch, a pulse down to depth. Hours later, the surface dries, the subsoil holds. Midday heat comes and goes, leaves don't flinch. Beds breathe at dawn. Less runoff, less pumping. The same field needs fewer inches because it carries its own reserve. A hand presses and the soil springs back, spongy, storied. In dry weeks, plants sip what the storm left behind. Attention becomes storage. The reservoir is underfoot. The field learned to store water. Towns learned to store certainty. Cut to reservoir signage, Stage 1, Stage 2, Stage 3. Clear, predictable steps. Trigger points tied to reservoir levels. Soil moisture reports, and demand curves. When the gauge drops here, outdoor watering shifts there. Evenings only, then odd even days, then no turf. Fewer inches on purpose. Pipelines under streets. Control rooms glow, valves mapped. Pressures balanced. Aquifer storage and recovery. Winter surplus cleaned, injected, banked below town. In summer, the well field runs in reverse. A quiet underground reservoir. No new dam, just timing. A dry year stretches. Emergency interties click open between neighbors. A 4-mile pipe bridged last decade comes alive. Portable pumps staged, generators tested, chlorine residuals tracked. Tabletop drills mean the real day feels familiar. Community meetings, calm, plain language. Here's our threshold, here's our next step. Empty fountains become billboards for restraint. Digital dashboards show yesterday's use, today's goal, and who's helping hit it. Text alerts go out before lawns turn brittle, nudges, not alarms. Fairness built in. Parks shift to drought pallets. Businesses get tailored schedules. Rebates move first. Smart controllers. Soil moisture sensors. Leak fixes. Enforcement is a conversation, then a citation if needed. The tone stays steady. ASR wells hum at dawn. Interties idle, ready. The playbook adapts each season. Less guesswork, more protocol. Attention becomes storage at the town scale too. When storms leave and weeks go long, the plan carries a reserve. Coasts write their own drought playbook. Same clarity, different tools, wide unbroken shots. Solar fields tilt toward a pale horizon.
Midday power runs reverse osmosis when the sun is strongest. Batteries carry the edges. Permeate goes to ground-level tanks. Stored certainty, not just stored water. Intakes sit quiet under the swell. Low-velocity wedge wire screens, or subsurface galleries buried in sand. Fish slide past. Silt stays out. Pumps sip, not gulp. Inside, energy recovery devices do the heavy lifting. Pressure borrowed, pressure returned. Fewer kilowatt hours per liter. Operations flex with weather. Ramp up on blue days, idle when storms roll. Outfalls are diffusers, not dump pipes. Multi-port jets that spread and mix brine fast. Plumes modeled, then measured. Salinity sensors stream to dashboards. If coral says enough, flow shifts or pauses. Night shots of coral gardens glow, untouched, monitored, alive. Reuse is a rule, not an afterthought. Purple pipes lace resorts and neighborhoods. Cooling towers, irrigation, street cleaning, fit for purpose. Advanced treatment takes the rest to drinking standards when needed. Every drop works twice. Fishermen tie off at dawn. Their maps sit beside plant schematics. Intake windows avoid runs. Zones move with seasons. A council meets monthly. Operators, divers, skippers. Protocol, not surprise. Storage stacks. Tanks on hills. Cisterns under plazas. Even hydrogen pilots at outer docks. Storm roofs catch first flush. Chlorine residuals tracked like tides. Brine becomes a product where it pencils. Salt pans. Magnesium recovery. Pilot crystals. When it doesn't, diffusers and dilution do the job, proven and watched. Hurricane glass, elevated switchgear, quick connect manifolds, plants harden without hiding. If a line fails, an inter-island pipe clicks open. Portable pumps arrive before shortages do. Shot of a beachside screen, yesterday's production, today's goal, plume status, green. Calm voiceovers at town hall, here's our threshold, here's our next step. Solar, desal, storage, strict reuse, oceans respected, islands that once hauled water now bank it, abundance by design, pace to the sea. Slow portraits, sun on faces, not spotlights. Hands, not just hardware. Dashboards on a tablet, dashboards on a wall screen, dashboards on paper at a market stall. Numbers read aloud in many languages. Big fonts, clear icons, offline modes. Volunteers lean over river rails with testing kits. Drop, swirl, compare. Upload from a phone. Sensors zip-tied to bridges, wells, rooftops. Solar buttons blink alive. Community calibration tables, distilled water and reference cards. Care and focused faces. Training makes stewards. Teens in training. Aunties learning. Skippers and custodians. Stipends, certificates, pride. Data returns value. Leak crews dispatched to red dot clusters. Rate relief tied to savings. Filters delivered where taps fail most. SMS for storms. Voice calls for elders. Haptic buzz when reservoirs dip. Consent is a checkbox in a conversation. Private wells remain private unless invited. Water Council reading graphs together. What do you see? Replaces, here's what you missed. Equity audits beside flow meters. Maps show renters. Maps show schools. Maps show clinics. APIs open but guarded. Personal data masked. Community rules on data sharing. Scan QR at a pump. Yesterday's draw. Today's plan. Complaint links. Response clocks. Classroom. Coding simple alarms. Mending a probe. Logging field notes. Microgrants buying bench scales. Sample fridges in a local lab. A shared laptop everyone trusts. Dashboards tracking promises, green or amber. People tracing surprising numbers together. Community stewards holding keys. Water data as common ground. Transparent, useful, humane. Coins fall in slow motion, ripple like rain. A ledger turns, rows become rivers. The question, how do we pay for resilience fairly? First, lifeline tariffs. A guaranteed basic block of water at low or zero cost, enough for health. Dignity. Above it,
Tiers that reflect real demand. Cross subsidies from heavy use to essential use. No shocks. No shutoffs for the lifeline. Clear bills. Big fonts. Many languages. Pipes under streets glow on the balance sheet. Pay for performance contracts. Fund leak reduction. Utilities and local crews get paid when losses drop. Verified by open data. Independent audits. Community dashboards. Savings share back to keep fixes funded. Meters click. Not to punish, but to measure outcomes. Prepaid pitfalls are flagged. Credit protections. Grace periods are standard. Equity screens test every rate. Does it burden renters, clinics, schools? If yes, redesign. Climate bonds raise capital for drought proofing. Reuse, storage. Proceeds traced to projects like a trail of blue ink. Disclosed, audited, mapped. Coupons linked to milestones. Liters saved. Outages reduced. Contamination incidents prevented. Miss the mark, pay more. Meet it, pay less. Blended finance lowers risk. Public guarantees. Impact tranches. Local banks. Revolving funds turn leak fixes into future savings. Microgrants seed neighborhood repairs. Stipends train stewards who verify results. APIs are open but guarded. Personal data masked. Community rules decide what's shared. Dashboards track promises. Green, amber. So trust compounds like interest. The price of a drop is not just cents, it's governance. Transparent formulas. Consent as policy, not just a checkbox. Finance that sees the unseen, informal settlements. Elders, night shift workers. When money flows with proof and care, water follows, reliably and without bias. Follow a drop downstream and it becomes a watt. The energy-water loop closes in quiet ways. In irrigation canals, micro-turbines hum under grates fish-safe, low-head, tuned to steady flow. No dams, just harvest what already moves. SCADA screens show kilowatt-hours next to liters delivered. The deal, revenue pays for pressure stabilization and leak fixes. Batteries where the grid blinks. Pumps that start when the sun sets. At river mouths, pilots test salinity gradient power, membranes that make electricity from salt meeting fresh, pressure-retarded osmosis, reverse electrodialysis. Estuary labs breathe with the tide, modeling flows to guard nursery habitats. Brine returns are balanced, open data pings. Watts produce salinity shifts dissolved oxygen, green when safe. Across reservoirs, floating solar drifts like tiled lily pads. Panels shade the surface, cutting evaporation. Cooler water, cooler cells, more efficient power. Anchors flex with wind. Rafts leave lanes for birds and boats. Algae falls back. Intake pumps sip clearer water. Dashboards count two currencies at once. Megawatt hours and cubic meters saved. Contracts align with outcomes. Paid for verified watts and verified water conserved. Community energy co-ops own slices. A share on the bill, a stake in the lake. Equity screens ask, who benefits first? Clinics pumps, cold chains. Alerts route maintenance before failure. Storm mode lifts arrays. Drought mode shifts flows. Blue energy doesn't conquer rivers, it collaborates. Canals that light villages. Estuaries that power labs, reservoirs that keep their own. When electrons ride on water's paths, resilience scales, quietly, efficiently, and in sight of everyone. At sunrise, the village exhales. Roosters stitch the quiet. Sandals whisper on dust. Under a solar hut, small atmospheric water harvesters wake. Fans low, coils cool, breath turning to beads. Children line up with bottles. Click, fill, smile. A tap shuts. A drop lingers. It falls into a bucket marked school. Next tap, clinic. The cold chain fridge hums. Vaccine safe because the cloud came down last night. Technicians in faded caps move like clock hands. Filter out. Filter in. O-rings checked. A cloth wiped along a fin until it sings. The maintenance ritual is half prayer, half protocol. Bolts torqued. Silica gel dried in the morning sun. QR code scanned to log hours. On the chalkboard, liters made. Filters due. Kilowatt hours used. 2 currencies balanced at eye level. Power comes from the village itself. Panels on the hut. A quiet cable from the canal micro-turbine upriver. Blue energy meets blue sky. When the grid blinks, batteries carry the dawn. When the air runs drier, timing shifts to match cooler hours. The system listens, humidity, watts, demand. It sips when it should, drinks deep when it can. Ownership lives in hands, not headlines. A women's water committee runs the rota. Each household holds a co-op share. Dividends from canal watts buy next year's membranes. The parts library fits in 2 metal trunks, paid for by the town's water and light ledger. A sticker on each unit reads, "Hours." Ambient sound swells. Laughter. A kettle. The soft thrum of fins. A WhatsApp ping confirms last night's yield. A teen posts today's numbers to the open dashboard. Equity screen stays green. School and clinic prioritized. Homes next, gardens last. By noon, the clinic cooler is topped. The school barrel's capped. A breeze flips the edge of a maintenance sheet. The village cloud keeps forming. Small, steady, local. Not a miracle, a practice. Water from air. Electrons from flow and sun. Resilience, measured in cups poured and shots kept cold. And every evening, the harvesters rest as the sky cools again, ready to breathe tomorrow. From orbit. Earth rotates, a blue-brown pulse. Instruments stare without blinking. Grace, foe weighs the planet, sensing aquifers thinning by micro-changes in gravity. SMAP maps soil moisture across continents. Sentinel watches fields green, then gray. Landsat watches fields green, then gray. INSAR measures land sinking where water is mined. Cut to ground. A dry well is tagged on a phone. Red pin. Another, amber. A farmer pushes a soil probe. Moisture readout uploads. A schoolyard rain gauge tips. A teen scans a QR code. Timestamp logged, GPS logged, millimeters logged. A hydrologist lowers a tape into a monitoring borehole. Echo, then number. Return to orbit. Data tiles tessellate a dashboard. Basins in blue to brown. And open API streams. Reservoir levels. Evapotranspiration. Recharge estimates. A map layer flickers. Subsidence risk corridor. Another, irrigation windows. Cooler hours prioritized. Back to ground. A village committee reads the screen. Clinic first. School next. Green bands match last night's harvest. Up the valley, a red cluster of dry wells triggers a text. Tanker dispatch. Drilling moratorium. Leak hunt scheduled. A policy page opens. Allocation update justified by transparent curves, not rumor. Orbit again. Monthly grace anomalies smooth into trend lines. Ground again. Field teams verify with salinity strips, flow meters, citizen notes. Trust grows where the map matches the mud. The system listens, satellites. The system listens, gravimeters. The system listens, gauges. The system listens, phones. Seeing the unseen turns into doing, pumping caps before subsidence, planting time to stored soil moisture, compensation when cuts are shared. Monitoring isn't a headline, it's a feedback loop. Transparency drives action. After silence, the river roars. Streets gloss, black fields shine like mirrors. The map that watched drought now watches deluge. Dashboards flip from brown to blue. Sensors, ping gauges leap. Abundance becomes a blur, racing away. Paradox, too much, then none. Wells taste of silt. Pipes breathe air. Tomorrow's thirst hides inside today's flood. We slow the water. A curb cuts to a bioswale. It swallows a curb's worth of storm. Permeable pavement drinks the first inch, then the next. Tree pits widen. Roots become wicks. Roofs turn moss and sedum. A million leaves hold a million drops. Plazas sink a little by design. A public square becomes a brief lake, then a memory. Floodplains reopen. Levees step back. The river reclaims its bed for a day, and we reclaim storage for a year. Wetlands rehydrate the planet's kidneys, store and release on time. Infiltration basins yawn open underground. Cisterns fill, slow heartbeat under streets. Data guides the doors. Satellites, gauges, phones' windows appear on the dashboard. Cooler hours, sandy soils, open pores. Valves turn, spreading fields. Light up on a map. Slow spread sink. Managed recharge. Pushes the crest into the ground, not the sea clinic first. School next, the grid of blue becomes a calendar of security rivers. As teachers, floodplains as vaults, cities as sponges. When floods teach thirst, we listen. We keep what comes in a rush, so it stays for the long walk ahead. After floods teach thirst, we teach each other. Classroom lights on curiosity awake. Curricula that start with a map. Trace the gutter to the creek to the river to the bay. Name the water you live with. Maker kits spill onto tables. Soil probes blinking. Bottle rain gauges catching today. Turbidity wands painting light through water. A hallway mural turns into a live dashboard. Kids wire sensors, then wire stories. Zines, podcasts, short films. Elders remember the high water line. Farmers explain slow spread and sink. A language of rain travels between generations. School gardens become small watersheds. Swales curve, barrels breathe, tree pits widen like open hands. Seeds learn the calendar of cool hours. Creek cleanups turn data into deeds. Waders, grabbers, buckets of evidence. Trash sorted into patterns, then solutions. Microplastics named, not ignored. Bell rings, valves turn, drip lines. Listen to student dashboards. Green flags for cooler hours. Blue pins for sandy soils. Action braided to understanding kits go home in backpacks. Apartments, farmhouses, shelters, clubs. Translate lessons across languages. Every block gets a water steward. A curriculum that ends outside. Field notebooks, damp at the edges. Badges for caretaking, not just quizzes. We graduate watershed guardians. A million small scientists, measuring, mending, telling. So the water we keep in a rush stays for the long walk ahead. Dawn over skylines, dusk over fields, night across the open ocean. The next 10 years arrive like a tide we can read if we choose. Milestones to track, simple, public, shared, safe water within 200 meters for every household. Boil notices fall to near zero. Non-revenue water below 15% in every city. Leaks mapped, fixed, verified. Aquifers rising. At least 1% annual recharge gains in stressed basins, guided by ancestral wells and new ledgers of ice and rain. Wetlands restored. 350 million hectares as living kidneys. Floodplains reconnected by the thousands of kilometers. Circular water. 30% urban reuse. 80% of cooling and factories on reclaimed flows. Farm fields that listen lifting soil moisture by 10%. Evaporation losses cut with covers, shade, and smart timing. Reservoirs breathe less. Crops breathe better. Microplastics and PFAS declining year on year. Sensors naming the invisible. Early warnings for flood and drought reaching every phone. Open dashboards in every school. Risks to avoid. Named so we don't drift, mining groundwater to silence, privatizing rivers without voices, building debt-heavy pipes that crack trust, tech without consent, data without equity, heat stacking on thirst, salt climbing into roots, ecosystems crossing lines we can't redraw, conflict over drops when cooperation costs less, the pathway we share. Protect headwaters like temples, recognize rivers as persons, pay the true price of a drop, and return value to the source. Let farms harvest vapor, and cities run on circular blue. Power desal and treatment with clean energy. Put wetlands back, soil first, and islands of abundance where deserts once grew. Keep the glacier ledger honest. Make the hidden network visible. Teach, measure, mend, together. At decade's end, the test is simple. More life per liter, more trust per plan. Hold the line, move it forward. The water we save in a rush must last the long walk ahead. Cut to black.